All right, here we go. Okay, we've talked a little bit before about congruent figures. What does congruent mean? Anybody know what congruent means?
Same.
Exactly the same, right? Okay. Congruent means that things are the same. And if you remember, think back to when we did corresponding sides. What is something, if something is corresponding, what does that mean? Same in one figure as another one, right? Okay. So this is kind of like congruent, okay, except these are what we call similar polygons. Okay. Does similar mean exactly the same? No. Okay. Similar means same shape, but not the same size. Okay? Think about like when we did dilations, okay? It's almost like when you click on a shape when you're in PowerPoint and it has that little corner, and when you drag your mouse, what happens to it? It gets bigger, right? It doesn't change the shape though, right? Okay? That's kind of like what we mean by similar, okay? Figures are similar if their angles are congruent, and congruent again means what? The same, and sides are proportional. Now, does proportional mean the same? It means equivalent. So proportional means that when I set them up, okay, the sides, if I set them up as a proportion, they should equal each other. And I can determine that by doing my cross products, right? Okay, so does everybody have this written down? Okay, so let's say that I've got a figure, let's say I got a triangle here. Okay, let's just say I got one triangle here and another triangle here. And let's give this some labels. Okay, let's say this is triangle A, B, C. And this is triangle D, E, F. And let's say that over here on A, I've got one mark here, I got 2 marks here, and then I've got 3 marks here. And in this one, I've got 1 mark here, 2 marks here, and 3 marks here. Okay. And let's say this is 4, 6, 8, and this one is 6, 9, 12. Okay. And let's say that I'm asked, the question is triangle ABC similar to, now when you see this sign right here, what does this means? Similar to. Okay. Does anybody remember what this sign means? Congruent. Okay, this means congruent. Okay, so is triangle ABC similar to triangle DEF? Okay. Well, what I'm going to do in order to determine if these are similar, the first thing I'm going to do is I'm going to see if the corresponding angles are congruent. Okay. Look at angle A. Okay. What does it correspond to over here? D. Why? Because this one has a what? This one has 1, so this one has 1, right? Okay. So I'm going to say angle A is congruent to angle what? D. What is angle B congruent to? Angle E. And what is angle C congruent to? Angle F. Okay? Remember, polygons are similar if their angles are congruent. Now, congruent means exactly the same. If I had a measure here for angle A, let's say measure of angle A was 30. What would that tell me? That angle D has to be what? 30. Okay, does that make sense? That means they're exactly the same. Now, when it talks about corresponding sides, okay, well, pick a side on this first one. Okay, so that's BC, right? Okay, so I say that BC, bless you, is similar to, okay, what's BC going to be the same as over here? EF. Okay, why? Because BC goes from 2 to 3, right? From 2 to 3 on this one is 9, okay? So this would be 6 over 9. What can 6 over 9 reduce to? 2 over 3. Okay, pick another side on this first one. E what? No, in this first one. AC, okay. So if I do AC, what is AC proportional to over here? DF. And AC is 8. DF is 12. What does this reduce to? 2/3. Okay, and the only side we haven't chosen over here is AB. What is it congruent to over here? Or similar, it's the same as? DE, right? Okay, and AB is 4, DE is 6. What does this simplify to? 2/3, okay. So what we would say is that yes, these two are similar because all of those simplify to 2/3, okay, and all of those angles are congruent to the other angle. Does that make sense? Yeah? Now, if you were to simplify this, let's say this one was 2/3, this one was 2/3, and when I simplified this one was, say, 3/4. Okay, would that mean they are similar? That would mean they're not similar. Okay, does that make sense? All right. Are we understanding so far? Okay. Now, when we use, can I erase this? Okay. When we use a similarity statement to determine a missing side, we're going to set up a proportion, okay? If we do proportions to find a missing side, it's easy. All we have to do is find our what? Cross products, and then solve for the variable, okay? So if, let's say, for example, let's say you're told that KLMN, what does this mean? What does that mean? Is similar to, okay, PQRS. Okay, and let's say that I've got, this one is a rectangle, and we'll have a smaller rectangle here. And we are told that these are similar. We're not determining whether they're similar, we're told they are similar. Okay, so let's say that this is KLNM, and let's say this one is PQRS. Okay, and let's give this some measurements. Let's say this one is 4. Let's say this one is 5. Let's say this one is 3, and this one is X. Okay. Well, the thing about this is the order that these are in are important. Okay. In other words, what are the first two here? KL. What are the first two in this one? That means KL is proportional to what? PQ. So when we set up our proportion, okay, what is KL? KL is proportional to PQ. And what is the other one that we have? KN, which is the first and last. What are the first and last here? PS. Okay. I wrote this wrong, sorry. This should be SR. Okay, so PS. Remember, what did I tell you guys about proportions? You have to have, when we found proportions to find missing shapes, you have to have the same units on the same levels, right? So this shape, KL, is from this first one. So where should KN go? Up here, right? So KN over PS. Now let's give this some numbers. What is KL? 5. What is PQ? X equals, what is KN? 4 over what? 3. Okay. Well, how do we determine this now? Find our what? Cross products. Okay. What's 5 times 3? What's 4 times X? 4X. How are we going to solve this? Divide each side by what? By 4. And what do you get? X equals 3.75. Okay. You see how you were able to use a similarity statement in order to find those missing sides. Okay. Does that make sense what we did there? Sort of? A little bit? Kind of? All right, let's try this one. Okay, if I have this triangle, okay, let's say here's my triangle. I have another one right here. And let's say that on this one, I got angle 1, angle 2, angle 3. This one I've got angle 1, angle 2, angle 3. Okay. And let's say, and I'm not even going to put sides here. Let's say this is 6, 12, 15. And let's say this is 4, 8x. Okay. And all I'm told is that these triangles are similar. Okay. If I'm told these triangles are similar, I can use this to find a missing side. Okay. And you can pick whichever ones you want. Okay. Pick a side from here. Somebody. PJ, pick a side from this first one. 6, this one? Okay, so 6. What is 6 proportional to? This goes from angle 1 to angle 2. What is it proportional to over here?
4.
Everybody. 4. Now, the other one that I have to choose is x, because that's what I'm what? That's what I'm trying to solve for, right? Now, this x, is it going to go up here? It's part of the second shape, so it's going to go where? Down here. What is x proportional to in this one? 15 would be right here. Okay? Now, how do I solve this? Find my what? Cross products. What's 6 times x?
6.
What is 15 times 4? 60. Divide each side by 6. What is x?
10.
X equals 10. Okay? Does that make sense how we found that? It's pretty simple once you get the hang of it.
Yeah.
All right? Okay, that's all I got.